过来就好了。
哦，成功了，好 ，OK，好，不行，虽然说 Jonathan 不在，但这个是要为未来的这个职训预备的。
Jonathan 有梦。
而且今天好像没有远端的朋友哎，Concurrent Viewer 2。哦，好哦，那我们应该可以开始了。OK。好，so today will be the easiest lecture in the whole lecture series about programming language, and next week or 2 weeks later it will be the hardest one, talking about subprogram. But so today should end before 6, I hope. Okay. And before I begin, this is an appetizer. Jimmy, the guy online, he shared this JavaScript thing with me. So in JavaScript, you can do something strange here in the first line. And then you initialize an empty array. But the 0th element of the array is LOL. And the reason why this happened has to do with how JavaScript work in their OOP magic, which I will not be explaining here because it's not very healthy to know. But if you if you work on vanilla JavaScript, you probably want to learn the behavior, and I might be able to talk about this kind of design model in the lecture about OOP. So course announcement again, because some people are not here last time. So we will post slides and video and streaming link on our Gitter community, and all syllabus are on Notion, where we will also update the slide and the video on Notion. And if you give me your Gmail, I will send you the slide one day before. Okay. So today we only have 2 simple topics. One is expression, another is I mistyped it. Another is statement, not side effect. So we talk about expression and side effect only. So let's start from what is a expression. An expression is a syntactic entity in a programming language that may be evaluated to determine its value. Its value. Okay. And let me give some example. So you know all these kind of stuff before. You probably don't call them expression, but sometimes it helps to distinguish between the concept. So, for example, x is if you write a variable, it's a simple expression, and the expression evaluates to the value in the memory location represented by x. So you probably know this. You just didn't express the concept this way. And we also have arithmetic expression. So here you see we can have multiple smaller units whose composite who can compose a more complicated expression. So the value of this expression would be x. Because x is an expression, so x can evaluate to a value, and then the value plus 1. That would be the value of this expression. And then we have some more expression like function. A function call expression is it usually evaluate to the value of the return value of f, given x as input of f. So this would be a expression. And then you have like class construction expression. It evaluates to the instance of type class A by constructor, by a class constructor given input A. So all these are simple concept about simple expressions. Now we can have some more expression like x equals 1. This is called a assignment expression, and usually in almost all programming language I see assignment expression doesn't evaluate to any value. So in C++, assignments evaluate to like null. What does that mean? It means if you write something like y equals x, y assigned to x assigned 1, then this would yield x equals 1, but y equals null, because the assignment expression evaluates to nothing. And then we have increment expression. We have x++ and ++x. I think this exists in both JavaScript and C++, but Scala doesn't have this. Anyway, this means these two things they do. You can if you have known these two expressions, you know they do the similar things. They add x by 1, but they evaluate to different value. Here, forget about the R value and L value for now. X++ evaluates to the value before increment, and ++x evaluates to the value after increment. And here I introduced the concept of L value and R value because these are the terms quite common in C++ literature. We say something is a L value if it can appear on the left-hand side of an assignment expression. So you have learned assignment expression. So if something can appear on the left-hand side here, we call it a L value. And if something can appear in the right-hand side, we call it if something can only appear on the right-hand side, we call it R value. So what does that mean? It means since ++x returns a L value, so you can do something like this. Because it is a L value, so it can appear on the left-hand side. But you cannot do something like this. So that's the difference. And the reason why is actually there was a debate in C++. People are trying to argue about which one is faster. Should we write x++ or should we write ++x? Which one is more efficient? And so let's see. So we know that let's say, because we have the concept of like a variable is actually pointing to a actual memory location which holds a actual value. So if this is x, what happens if I do x++? If I do x++, it becomes make it a 2. But here the problem is x++ requires us to evaluate to the value before increment. But the memory cell has already been changed from 1 to 2. So the only way compiler could return the value before is it need to generate a temporary variable that points to the value before increment. So when you write things this way, compiler actually allocates extra memory space. So it's argued that this is less efficient. But this is actually not important, because usually compiler is smart enough to know if this is needed, depending on whether if you are just doing this without wanting its value but only want the increment, then compiler would be able to know that they don't need to allocate this. One example would be in C++. you can write something like, you can write a semicolon, and same as JavaScript. This semicolon means I'm not interested in the value of this expression. I only want the side effect. So I'll talk about that later. But when compilers see this, compiler know we don't have to allocate this extra space because the value of the expression is not needed. Okay, so that's it for the first topic. Now moving on to the second topic about statement. So far so good? Okay. A statement is a syntactic unit of a imperative programming language that expresses some action to be carried out. So this is kind of abstract and almost looks like the definition of expression, except when we look at an expression, we care about its value. But when we look at a statement, we care about its action. And in C++, it's you can think of a statement easier. It's just an expression plus a semicolon. It's a statement because if you add a semicolon, it means you don't want the value. You only want the side effect. So it is basically an expression whose value is not wanted. So that would be a statement. And an usual case would be assignment. We usually write assignment statement because we are not interested in the value of the assignment. We only interested in the action that happened. X is assigned to 1. And for increment, a lot of time we don't care about its expression either. We just want to increment something by 1. So if we don't want the value of the expression, then what do we want? We want the thing is called side effect. So this is the term that used to describe the context or memory that's being changed by carrying out the execution of a expression or statement. So for example, x equal x, if we assign x to 1, the side effect is we change the content of x to 1. If we do this x plus plus, the side effect is updating the content of x by its value plus 1. And plus x has exactly the same side effect, just different evaluation value. So sometimes it helps for us to understand a program, to know about what are the side effect and value of each expression in the programming language. Sometimes it helps us write a shorter code. So what we talked about was assignment, but also I/O expression like print. It also causes side effect because it's writing character string to a stdout file descriptor. It's also changing the context, changing the display. So these are the most common two things that would yield a side effect. And I/O expression doesn't just include like printing to screen. Also, when you write to I/O, when you change system clock, when you change environment variable, all those would be considered expression that would yield a side effect. Okay. So the term side effect is a bit strange, and here is an explanation why. So this is a piece of JavaScript program. If I have a local variable x equals 1, and I have a function f, doesn't take in anything but increment x by 1. And I call f here. This x becomes 2. So the call to f yields a side effect due to the assignment statement x plus plus. This is why we call it a side effect, because it's like something that's not obvious from the main code, but as a side effect that it changes the variable. And so this brings me to these two terms. First is a referential transparency. This term referential transparency means contexts do not affect the meaning of expression. By meaning, I mean actually you can just say it's return the value. So if context do not affect the value of a expression, then we say the program is referential transparency, and referential opaque is the opposite, where context do affect the meaning of a expression. And let's look at the example here. So remember, a function call is an expression that's established in the first section. So function call is expression. The expression evaluates to the return value of the function. But the problem here is you see the exact same expression evaluates to different values for each call. So therefore, this is referential opaque. So far so good. It's because context, there is a context X floating around in the global scope that's affecting the evaluated value of the expression. So it's referential opaque. So in a referential opaque language, expression, if you have a identical expression and you check for their equality, it might not be true. So in this case, f a call to f would not equal to another call to the same f, and this makes a program a bit hard to read. So I'm going so fast. It's almost done. So let's talk about a few cons for side effects, and this would prepare us for the motivation to learn functional programming language also, due to the bad nature of these side effects. So first, it's hard to read, like the previous example. Like how could you ever understand why 3 calls to f give you 3 kind of value? And second, is hard to prove. I will have a very interesting slide later to show how it can make a program incredibly hard to prove. And then it prohibits optimization. So check out this example. If we have expression plus expression, compiler cannot optimize it to 2 times expression, because in a referential opaque language, first is a side effect cause it calls referential opaque. So if a language has a side effect, we cannot guarantee expression always evaluate to the exact same value every time. So compiler cannot do this kind of optimization. And then it also makes parallel processing very difficult. So suppose we have expression 1 that read from X and expression 2 that writes to X. So expression 2 is the one that has side effect. If you're just reading the context, you don't have it doesn't count as side effect, but the expression 2 can write to X. So there is a side effect here, causing the whole thing to be referential opaque. So if you have expression 1 plus expression 2, the result would be very different if you execute this one first and this one, or this one first and this one. So if they are evaluated in parallel, you have a undeterministic result. So referential opaque is a really bad thing in terms of all these problems. And let's look at this example. So this is a piece of very simple program. And can you tell me if the last expression here is that true or false? This is the kind of program you can write with side effect. And let's trace it out. So x is 1 here. X equals 1 here, and I call f. So now x becomes 2. I call it again, x becomes 3. Now there is a x plus plus here. So here x becomes 4, but x plus plus returns the value before plus plus. So this is evaluated to 3. And then after this is evaluated, x is evaluated, so x is 4. So 3 times 4 equals 4 plus 4 plus 4. So this evaluate to true. But it's amazingly hard to prove. Okay. And now there are something that, again, I mentioned portability. I mentioned parallel issue. Side effect makes program hard to do parallel. Side effect also have a portability issue. For example, if we have these 3 functions. The first one and third one will always increment x by 1, but one returns the value before, one returns the value after. F2 returns the value before x minus 1. Now, how would this expression be evaluated? And you would think, yeah, usually programming language would do a... So you think usually programming language define operator precedence, and that is true. All language specify operator precedence, but usually they don't specify operator evaluation order. What does that mean? That means so if our expression is evaluated in the same order as operator precedence, then in this case, because multiplication has a higher precedence than addition, and if the programming language say we evaluate from left to right, so we run this F2 first. F2 would plus x, but return the value before, and F3 would run plus x, but returns the value after, so now x, this is a 3. F1 would, I forgot the parenthesis here. Then, oh wait, sorry, F2 is minus, so F2 is minus and returns the value before, so it's 1 here. Now x becomes 0. Now F3 would do a plus, returns the value after. And then F1 would do a plus, returns the value before. So yeah, so we get 1 plus 1 times 1, 1 multiplied by 1, so we get 2. But if it's evaluated from left to right and then respect operator order, then the result would be different. If we evaluate F1 first, x plus plus returns the value before, plus F2 returns the value before. Oh, I give a bad example where they return the same value. Maybe I should let it be F2 or F1 here. Yeah. So I hope you get the point. I give them the I thought it's impossible to give an example where they become the same, but I just
I think it's different.
It's different?
Yeah, because
So-
F2 is true.
Oh yeah, right.
Yeah.
Oh yeah, I'm mistaken. Thank you. Yeah, and F3 would return 1. Oh, 2. Yeah. So this gets you get 5. Okay, so why do I say it's portability issue? Because you might, for example, in JavaScript, you might be testing it all right on Chrome, but like on another browser, it evaluates to another order. But since all your end-to-end and unit test runs on Chrome, so you never know the bug. So this is why I call it a portability issue. Because usually language doesn't specify operand. Typo. Usually language doesn't specify an operand evaluation order. So they left it to compiler to decide what are the evaluation order. So yeah, so if we write a piece of program without side effect, then argument evaluation order is immaterial. So no matter what kind of evaluation order they take, it should evaluate to the same result. Because if you don't have side effect, you have referential transparency. That means expression evaluate to the same value, no matter when they are evaluated and how many times they are evaluated. So purely functional language don't specify argument evaluation order because they don't allow assignment, therefore no side effect. Although that's not entirely true because you still have IO operations, but still they don't want you to write code that depends on argument evaluation order. So if we have side effect, then argument evaluation order is important. So some language decide to specify it, like Java. Java have a very strict left to right evaluation order, but most language don't. So you might be surprised. Actually, C++ doesn't specify evaluation order. So the big lesson today. Oh wait, haven't. Okay. So the good thing about specifying argument evaluation order for a language is it would increase portability because then every compiler have to respect language specification. But the problem is it will sorry, this is I think I'm writing a lot of things wrong. It should be the count should be it decrease cannot and does not. Yeah, so if you specify argument evaluation order, it decrease efficiency because it doesn't leave room for compiler optimization. And why is because like the first one, if you have expression plus expression, you cannot optimize it to 2 times e because it's strictly specified by the language that the first e should be evaluated before the second e. And the same is and another thing is it prohibits like expression 1 plus expression 2 to be run in parallel. Sometimes when they compile things to assembly code, they allow parallel stage. But if we specify evaluation order, then compiler cannot do this. And another interesting example in the bottom would be if like this here, if n equals 0, then n times everything should be 0. But if you specify a required order, this must be evaluated. So the left-hand side they have to have a 0, and on the right-hand side they have a 5 divided by 0, and then it would throw an exception. But if evaluation order is not required, then compiler can just decide to compile this whole code to 0, because mathematically 0 times everything is 0. So they can try to make up some smart rules for optimization. Okay, so the lesson is don't write code that depends on evaluation order, and use functional programming. So that's it for today. Yeah. So as I said, today will be the easiest one for the whole series. But next one is we'll talk about the design of sub-program, and that is a very complicated topic. Okay. Any question? Okay. Then that's it then.